everybody! Today we're going to talk about solving systems of equations. Today's learning goal is I can solve a system of equations by graphing. So you're probably thinking, what is a system of equations? I know what an equation is, but now what's a system of equations? Good question. A system of equations is when you have two or more equations that have the same variables. So it's just more than one equation. And so when we look at more than one equation, we're trying to figure out what pairs of numbers, what values of x and y make both of those equations true. Or if we have three of them, what pairs of numbers make all three of them true. And for what we're doing right now, we're just going to work with two sets of equations. When we solve systems of equations, there's several ways you can do it, and we're just going to talk about one way today. We're going to talk about how do I solve a system of equation by graphing. So if I have two equations, how do I solve those by graphing? And so basically what you do when you want to solve a system of equations by graphing is you graph the two equations and then you look at where they overlap. And so here I have two equations. So this first equation, y equals 2x minus 1, you might notice is in slope-intercept form, just like we talked about in the in one of the previous videos. And so I'm actually going to graph this first equation without using a table. I'm just going to use the y-intercept here, which is -1, because I'm subtracting. So I'm going to put a point here on -1, and then my slope is +2. So if I want to think about this, I can put 2 over 1, and so that's telling me that I'm going to rise up 2 for every 1 that I go to the right. So from my y-intercept, I'm going to go up 2 and go 1 to the right. And now if I draw a line through those 2 points, that line is going to be the graph of that first equation. Now my second equation here is not written in slope-intercept form. So I have two choices. I could rearrange this equation and solve for y, but I'm not going to do that. I'm just going to pick some points that will make this equation true. So for example, if x is 0, then y has to be 5 in order to make this equation true. So I'm just picking pairs of numbers that add up to 5. So now I'm again going to graph these points on my coordinate plane over here and see what I get. So now you can see that these two lines intersect or appear to intersect from my graph at the point 2, 3. So what I want to do is I want to substitute that point 2, 3 into both of these equations and see if it makes both of them true, and then I will know that that is my solution to this system of equations. So I can see down here, I already noticed that 2 and 3, 2, 3 was a solution to this equation right here because 2 plus 3 equals 5. So now I need to substitute 2 in for x and 3 in for y into this top equation and see if that makes that top equation true as well, and then I'll know that it's a solution to that one. So now the question is, remember I'm going to substitute 3 in for y and 2 in for x. So is it true that 3 equals, and I'm going to put a little question mark over the top here to show that we're checking this, 2 times 2 minus 1. So again, is it true that 3 is the same as 4 minus 1? Well, 4 minus 1 is 3, and that is equal to 3. So it is true that 3 is equal to 3, and so the point 2, 3 does make that top equation true. I substituted 2 in for x and 3 in for y. And so my solution to this system of equations, which I found through graphing, is the point 2, 3. 2 for x and 3 for y makes both of those equations true. And you can see that those two lines intersect at exactly one point, point 2, 3. Here's another system of equations that I can solve by graphing. So I am going to now graph both of these lines, and neither one of these lines is in slope-intercept form, so I'm just going to make two tables. Okay, so let's start with this top equation right here, and I'm just going to try to find points values for x and y that will make this top equation true. So I like to start with x equals 0. So if x equals 0, then this first part is 0, and 4 times what equals 4? Well, that would mean y was 1. I also would like to figure out where my line crosses my y-axis, so I'm going to make y equal to 0. And then I'm going to look at here, what do I need to multiply -2 by to get 4? Well, I know a negative times a negative is positive, so I'm going to make this -2. -2 times -2 is 4. And then let's just pick a couple other points. Okay, so let's make sure that all these points are in a line. So now that I've graphed these two lines, it looks to me like those two lines are parallel. And if they're parallel, that means that they're never going to intersect anywhere. So there wouldn't be any points that would make both of these equations true. If, in fact, these two lines are parallel, that means that there is no solution to this system of equations because the two lines are never going to have any points in common. I can check to make sure that both of these lines are parallel by checking the slopes of both of them. And if they have the same slope but different y-intercepts, that means they're parallel, but they're different lines and they're never going to intersect. So if I start with this line over here, I can see that from the y-intercept, it goes up 1 and over 2. So the rise would be 1 and the run would be 2, so that would give me a slope of 1/2 for that top line there. And then if I look at this line here starting at the y-intercept, I'm going to go up 1 and over 2 to get to the point right there. So the rise again is 1 and the run is 2. So these both have a slope of 1/2, and they do have different y-intercepts, so that means they're never going to intersect and they're going to be parallel to each other. So I would write for this system of equations that this has no solution. Now for this last example, I've gone ahead and picked some points for this first equation, and that's in this table right here, and then I put the points for the second equation in the second table. And again, I just picked values for x or values for y that would work and make the equations true. Now you can kind of see, if you compare these 2 points, they both have the point 0, 2, they both have the point -4, 0, they both have the point 2, 3, they both have the point 4, 4, and they both have the point -2, 1. So I can kind of see right away they have a lot of points in common. They must be the same line. So as I graph those points, I can see that those are both the same line. And anytime you have points, and as you're picking it and you graph both lines, you can see that they're the same line. Those two equations graph the same line. They're just different ways of writing the same equation. And when that happens, all the points on the line are solutions. And so we write that there are infinitely many solutions because there are an infinite number of points on that line. The answer to the free response question for Spillman's class for today is rainbows and unicorns. And now we're going to have a little review from my son Grayson.
These lines cross. They have one solution. These lines are parallel. They never cross. They have no solution. These are the same lines. The solutions are infinite. That was awesome. Let's celebrate by blowing something up. Boom!
Thanks, Grayson. All right, here are your free response and multiple choice questions. Go ahead and pause the video and answer those.